Hey guys, welcome back. Today we're going to review motion problems. It's going to be a high-speed review, so hopefully it'll be enough. But you can always look back on my old videos, either through Canvas or go straight to my YouTube page. Just search Karen Dirklinger, you'll find them. Okay, so high-speed review of motion problems. Make sure you have your justification sheet out and that you've memorized everything that there is to know about motion stuff. Okay, it's basically a repeat of all of this, but there's a little bit more. Okay, first of all, anytime you're talking about a particle or something, a turtle, whatever, when they say moving left, you write velocity negative automatically. Moving right, you immediately write everything that's in red. Velocity positive. Particle stopped. Velocity 0. Particle changes directions. Velocity changes signs. You don't even have to say the equals 0 part. It's implied. Okay, speed is the absolute value of velocity. Speeding up, velocity and acceleration have the same sign. Slowing down, velocity and acceleration have opposite signs. And there's two more as well. Distance traveled. Let me see if I have that here yet. This you should already know, I think. Distance traveled. Okay. For distance, remember that's the area under the velocity curve. So area implies an integral, and distance can't be negative. Whether I'm going to or from school, I've still traveled a positive distance. So distance traveled is the absolute value of velocity, but the area under that curve. Okay? Versus new position would be starting position or any other position that they give you. So often it'll be like position on the x-axis. So you'll say new position at whatever time is equal to some other position, often 0, a beginning, okay, plus the net change of velocity from whatever this point is to whatever this point is, okay? If they give me x of 0, this is a 0, but if the only other one they give me is x of 2, then this is a 2, okay? So if I want the new position at time 7, for example, then this would be 7, and this would be a 7, and whatever other antiderivative they give me. Okay, so these two numbers have to match, and these two numbers have to match. But the main idea, common sense, is if they ask for a new position, I need to know the starting position. Okay, now let me put it all into play. This is stuff you do need to know cold. Now let me appeal to your common sense of all of these things. Okay, if this is a velocity graph, then let's just discuss what's happening, okay? Everywhere velocity is positive, all of this means particle moving right, okay? Everywhere velocity is negative, all of this is particle moving left. So this particle is going left and then right. So it changes position right here, okay? If I said, where is the particle stopped? It stopped for a split second there before switching sides, but it's also stopped here and here. It started off stopped, okay? So particle stopped is velocity 0. All right, now let's talk about speeding up. Okay, remember, if I give you the graph, you can kind of do speeding up informally, okay? But you're going to usually have to use the formal definition, but let me just explain why it makes sense first. Speeding up. The speed is the absolute value of velocity. So right here, the velocity is 4 and the speed is 4. So let's look at this strip right here. We're going from a speed of 0 to a speed of 4. So clearly that's speeding up. This is a constant speed. This is slowing down. Okay, but now let's look at the blue region. This is a velocity right here of -2. But that means it's a speed of 2. So in this section, you're going from a speed of 0 to a speed of 2. That's speeding up. Constant speed. And here to here is speed of 2 to a speed of 0. That's slowing down. So informally, if I don't have to justify, if I'm just looking for the answer on the graph, I think of speeding up as going away from 0. These are speeding up. Okay, that's my informal justification. Speeding up is going away from 0. Slowing down is going towards 0. Okay, you could try getting away with saying because speed is the absolute value of velocity. But what they're really looking for, and what you need to know when it's not a graph, is the definition of speeding up and slowing down. Speeding up is when velocity and acceleration have the same sign. That's speeding up. Slowing down is when velocity and acceleration have opposite signs. Okay, let me explain why that works, okay? Let's find the velocity and acceleration on this graph. Just look at the signs of each of them, okay? Starting with velocity. Velocity is negative everywhere it's below zero. So all of this is negative velocity, negative velocity. So is this, but I'm going to skip that because that's just a constant speed. Velocity is positive everywhere above zero. So this is velocity positive, velocity positive. So I have velocity negative and velocity positive. Now let's look at acceleration. Acceleration is the derivative of velocity. So on the velocity graph, acceleration would be slope. Okay, so let's describe the slope. The slope here is negative. The slope here is positive. The slope here is positive, and the slope here is negative. So now let's look at what we said speeding up was. This was speeding up, and this is speeding up, and it's where they have the same sign, both negative or both positive. Okay? Slowing down would have been here and here, because velocity and acceleration have opposite signs. Okay? Speeding up, slowing down. Okay, now let's talk about distance traveled or new position, okay? So, this turtle starts 2 feet to the right of my mailbox. What is the position at t of 10? Okay, well, we know the turtle would have gone left this for this much and then right during this part, okay? But how far did they go left and right? That's the area under the curve. So you would figure out those areas, area of a trapezoid, and at t of 10, it would be my starting position of 2 minus the 7 and plus the 14, and my new position would therefore be 9 feet right of my mailbox, if I did my math right, okay? But what is that symbolically? Your new position, if it's on the x-axis, which it normally is, this would be the, let's pretend it's not a mailbox and it's the x-axis. The new position at time 10 would be the starting position at 0 plus the net change from 0 to 10 of this guy's derivative, which is velocity. That's the same as what we did here, okay? It's x of 0, which was 2, plus this doesn't have absolute values, so it's negative 7 and a positive 14. Okay, compare that now to total distance traveled. Okay, read this next question, and I'm trying to trick you on purpose. If I said, what's the total distance traveled by the particle? Now this 2 that I've given you is irrelevant. Doesn't matter. All that matters is the turtle went 7 feet left and 14 feet right, so the turtle traveled a total of 21 feet. And that's why total distance, you don't need the starting position. That's why the total distance is from A to B, absolute value of velocity. Okay? Because this, we're going to call it a positive 7. You can't have a negative distance. You can't have a negative area. All right, now this, if it came to a problem that was an equation and not a graph. Okay, I'm not going to work all these out. We're just going to talk about them. Changing directions. I would immediately write velocity changes signs. And then I would do a sign chart to figure it out. Okay? Moving to the right. Velocity positive. Do a sign chart. Acceleration. Do the derivative and then a sign chart. All right, now let's focus on these two. Total distance traveled. This is most common, okay? Even if they don't say total, they just say distance traveled, okay? You want to immediately write the integral from 0 to 10 of the absolute value of velocity. Then hope and pray it's a calculator question, which it often is. If it's a calculator question, just make sure you know how to find the absolute values and put it straight in your calculator, okay? Now, if it's not a calculator question, then you have to handle these absolute values by breaking this up. So I would do a sign chart of velocity real quick. And we find t equals 2 and 3. So we're going to do a sign chart of my velocity. Okay. Left of 2, I'll plug in 0. We get positive. This will be positive, negative, positive. So how do we handle that? What we do now is we're going to get rid of these absolute value bars by separating this into the different sections. Okay. We're going to go from 0 to 2. Okay. Then we're going to go from 2 to 3. And then we're going to go from 3 to 10. Anywhere the velocity was positive, I'll leave it the same equation that you see here. You can get away with writing v of t, but you're going to actually have to integrate. But anywhere it's negative, since velocity can't be, distance can't be negative, anywhere it's negative, you have to change this to its opposite. Okay? You can actually put the negative out in front if you wanted to. Then if you have to work this out by hand, and by the way, usually when I have to work this out by hand, I don't usually find that it's even worth the time to do it. To be honest with you, this is often one that I would be like, okay, maybe at the end if I have time. Usually it's a calculator question. But just to make sure I explain it again, from here, I still have to actually integrate this in all three of these places. So in the first and third section, the velocity equation stays the same. In the middle section, change everything to its opposite. Negative t squared, positive 5t, and negative 6. Then integrate all of these by hand. Add 1, t cubed over 3, 5t squared over 2. Plug in the 2 and the 0 and subtract. It's just typically too much work unless they give you a much shorter equation. Okay? So what do I need you to get out of this? If they say distance traveled, you just most of the time need to know it's the absolute value of velocity, okay? Or sorry, the integral of the absolute value. Remember, distance traveled, distance is area under curve. That's why you need the integral, but distance can never be negative. Then you almost always get to just plug that into your calculator. If you don't, then these bars, you get rid of them by finding anywhere velocity is negative and flipping it to its opposite, okay? Now compare that to part E. New position. If it's a new position, then that one's a lot easier. It's starting position of negative 3 plus the net change from what I know to what I need of velocity. Excuse me. And if this is a calculator question, you can put it in Math 9. If not, it's still something you can do by hand because you're only going to integrate one time. You don't have to split it up. Okay, the integral automatically assigns negative to anything below the graph and positive to above. So you don't have to split it up or anything. All right, hopefully that's a decent review, guys. If not, let me know. Let me know if there's anything I can do to help, okay? Hope you're doing well.